For over 40 years, Voyager 2 has drifted silently into the void, moving farther than any human-made object before it. Launched in the 1970s, it carried with it the last whispers of Earth, a ghostly ambassador into the depths of the cosmos. We expected it to fade quietly, its signal dimming as it moved into the infinite dark. But recently, it sent back something that startled NASA scientists. Not routine data, not familiar readings, but a sharp, unexpected spike. An anomaly that hinted at a truth humanity had long suspected but never fully confronted. The edge of our solar system is not a gradual fading, not a gentle blur. It is a boundary. A wall. And beyond it, the universe changes. When Voyager 2 crossed the helipause, the supposed edge where the Sun's influence gives way to interstellar space, scientists expected a gradual transition. They imagined the solar wind slowly fading into the surrounding medium, a gentle merging of two cosmic domains. Instead, the change was abrupt. One moment it was in the Sun's protective bubble, the next it was in a realm where radiation surged by over 70%, plasma density jumped, and the magnetic field shifted violently. It was as though Voyager had stepped through a door into an entirely different reality. The precision of the boundary shocked researchers. The heliosphere, once thought to fade gently, revealed itself as a shield, protecting the solar system from the chaos beyond. For decades, the heliosphere existed mostly in theory, a magnetic bubble shaped by the solar wind, providing a buffer from galactic radiation. Voyager 2 proved it is more than theory, it is a lifeline. Inside this bubble, radiation levels remain manageable, plasma is steady, and cosmic rays are partially blocked. Outside, all rules change. Particle energy surges, magnetic fields twist chaotically, and radiation rises to dangerous levels. Suddenly, the solar system appeared not as a lonely outpost drifting in space, but as a fortress, and leaving it meant entering a turbulent, unregulated frontier. Voyager 2's data revealed further surprises. The heliosphere is not fixed, it breathes. It expands and contracts with the Sun's 11-year cycle, altering the protective barrier around us. Voyager 1 and Voyager 2 crossed at different distances, shaped not by random chance, but by the rhythm of solar activity. The heliosphere is distorted, almost comet-shaped, pulsing outward like a living organism. When the solar wind weakens, the boundary creeps closer, allowing dangerous cosmic rays to penetrate. When it strengthens, the shield expands, offering more protection. This revelation was unsettling. Earth's defenses are neither constant nor guaranteed. They fluctuate, and the cosmos outside is far closer and far more violent than we realized. In 2019, Voyager 2 experienced a brief, unexplained blackout. For a few hours, it went completely silent. No commands were sent, no updates issued. Then, without warning, the spacecraft rebooted itself and resumed normal operations. Official reports attributed the interruption to aging hardware or minor software glitches. Yet hidden within the data were notes on electromagnetic spikes, sharp magnetic fluctuations, and surges of particle energy just before the outage. Was it simply a technical issue, or had Voyager passed through a region of space unlike anything we had encountered? Some suggested a ripple from a distant supernova or a pocket of highly energized plasma, but others quietly considered a more unsettling possibility. Voyager had entered a previously unknown layer of the galaxy, one with unpredictable properties. Beyond the heliopause, the spacecraft began recording phenomena that didn't match any known models. Radiation and plasma readings fluctuated with a strange consistency, forming dynamic patterns that persisted over time. High-energy particles surged in waves, magnetic fields shifted direction unpredictably, and cosmic rays pulsed in rhythms previously unimagined. At first, scientists searched for explanations within the Sun's activity, flares, coronal mass ejections, echoes of solar disturbances, but the timelines didn't fit. The anomalies weren't caused by our star. They came from outside. The more Voyager 2 revealed, the stranger the universe became. The edge of the solar system was not simply a barrier, it was a threshold with its own weather, a violent, living frontier beyond human comprehension. Voyager's instruments captured variations in particle density, magnetic turbulence, and radiation intensity that suggested a structure, a hidden order in the chaos. The readings hinted at processes we had never considered, cosmic interactions on a scale so vast they defy intuition. The solar system's protective bubble is fragile, and what lies beyond is active, alive in ways we are only beginning to grasp. Voyager 2's journey forces us to reconsider our place in the galaxy. For decades, we imagined space as a void, serene and empty. Instead, the spacecraft shows us a frontier that is harsh, unpredictable, and pulsating with energy. The boundary of the heliosphere is not just a line on a map. It is a living threshold, constantly shifting, and we exist behind it in relative safety. Beyond that boundary, the cosmos is raw, unfiltered, and indifferent. Every spike, every magnetic twist, every surge of radiation reminds us that our solar system is a fragile island in a violent sea, and Voyager 2 is humanity's lone witness to the forces that lie just beyond the. Since its launch in late 2021, the James Webb Space Telescope has been humanity's most ambitious window into the cosmos. Its mission was simple on paper: study the formation of stars, galaxies, and planets to better understand the universe's origins. But what Webb has uncovered is anything but simple. Every observation challenges the rules we thought governed space, time, and matter, forcing scientists to reconsider everything they believed was true. In early 2024, while observing a dying star in the Carina Nebula, Webb picked up something strange. The star's collapse produced a rhythmic, low-frequency pulse, repeating with eerie precision. This was nothing like the chaotic patterns expected from stellar death. Some astronomers compared it to a heartbeat, others to a coded message from the star itself, fading as it collapsed into a black hole. Whether natural or deliberate, the idea that a dying star could leave behind a signal, an audible echo across the cosmos, raises unsettling questions. Could the universe itself be trying to communicate? While stars may pulse, entire voids of space may conceal far stranger phenomena. Webb's data, too vast for humans to analyze alone, was processed with advanced AI trained to detect anomalies. It flagged a region devoid of galaxies, stars, or dust, yet not empty. Within this void, gravitational distortions formed a spiral pattern, rotating, pulsing, and bending space itself. Hubble had glimpsed hints of this years ago, but Webb confirmed it. Whatever this entity is, it behaves in ways science cannot classify, a presence that moves and reshapes reality around it. Then there's the matter of time itself. In a sector near the constellation Fornix, Webb observed galaxies whose redshifts defied all logic. Light from distant galaxies appeared younger than that from nearer ones. Under normal cosmology, redshift increases with distance, a record of the universe's expansion. But here, time seemed to reverse. Some theorists call it a time fold, others speculate it could hint at errors in the cosmic fabric, or even a simulation-like anomaly. Either way, it challenges the very notion of linear time, leaving scientists with questions deeper than answers. Webb has also revealed strange, ancient objects that challenge conventional physics. Some galaxies, formed less than 600 million years after the Big Bang, already host supermassive black holes far larger than expected. The existence of these ancient giants suggests the universe evolved faster than models predicted, as if cosmic evolution had been accelerated. And in parallel, observations hint at dark stars, objects powered by dark matter rather than fusion. If confirmed, these stars could explain the abundance of black holes and rewrite the story of how matter coalesced in the early universe. Webb's observations extend beyond the distant past into the possibilities of parallel realities. A spiral galaxy was imaged with near-perfect symmetry, its spectral signature mirrored elsewhere in space. Both versions of the galaxy exhibited synchronized energy fluctuations and identical star cluster movements, almost as if two realities were overlapping. Could Webb be capturing echoes of a multiverse, faint reflections of alternate cosmic structures visible only through instruments of extraordinary precision? The telescope's discoveries also reach into the potential for life beyond Earth. Observations of GJ1214b, a super-Earth 40 light-years away, revealed thick water vapor clouds and methane in its atmosphere, hinting at possible habitability. Far from our solar system, Webb is uncovering worlds that may mirror the conditions of early Earth, suggesting life could be more common than we ever imagined. Organic molecules detected in galaxies over 12 billion light-years away indicate that the building blocks of life existed long before Earth formed. This hints at a universe teeming with potential for life, an environment where the emergence of biology may be inevitable. Every new observation compounds the mystery. Stars may pulse with signals, voids spiral with unseen forces, time itself may twist and fold, and galaxies appear fully formed far earlier than expected. Eye-assisted analysis is flagging patterns humans can't recognize, and Webb continues to expose gravitational anomalies that challenge our understanding of reality. What was designed as a tool to confirm theories is now revealing a universe stranger than science had ever imagined. The implications are staggering. The cosmos may not be silent, linear, or predictable. The rules we thought governed the universe may be mere guidelines. What we considered the beginning may only be a checkpoint, and the structures of space and time may be far more intricate and alive than we can comprehend. James Webb is doing more than observing, it is redefining what it means to look into the universe. And we are only scratching the surface. If this is what Webb has discovered in its first steps, the next revelations could be beyond imagination, bending physics, time, and reality itself. The telescope has not just broken expectations, it may have broken the framework of modern science. What comes next may redefine humanity's place in the cosmos